All right, so this is the second part of the explanation. So we were talking about this, the intensity I1, this one, I1 equals the sum of these three radiations together. Now, what about the radiation coming into the atmosphere? The amounts of radiation going into the atmosphere from the Earth's radiation, it is actually brackets 1 minus alpha times I1 because alpha is reflected back due to albedo. So the amount of radiation getting into the atmosphere will be brackets 1 minus alpha times I1. This is what it is here. And that amount of radiation equals to I3 plus I2 plus I2. I3, I2, I2. So the sum of these three radiations should be the same as how much radiation coming into the atmosphere. As a result, you have this. So 2I2 plus I3 equals to 1 minus alpha bracket times I1. Now, this is simply just a math problem now. So we have three unknowns, I1, I2, I3, and then so you have one equation, two equation, and the third equation, we have this. You just put them together, play around with the math, and then you will come up with those expressions, I1, I2, I3, like that. So after all, this is just a manipulation math puzzle question. It's not easy, it's not straightforward, but it is doable. This is just math after all. Okay, now what about part B? Part B, it says, showed that as much energy entered the Earth's atmosphere system as it leaves it. So that means, what are we trying to show? We want to show that how much energy coming in equals to how much energy coming out, right? So the intensity entering is S over 4, and the energy leaving, the intensity leaving is this much, alpha S over 4, right? Plus I3 plus I2, which is this one, and this one. So these three arrows represents how much energy leaving the atmosphere. This is how much energy coming in to the atmosphere. And well, if you use the previous representations, I1, I2, I3, okay, for this, so this is I2 and I3. If you replace I2, this representation by this, and replace I3, this representation here, and this is S over 4 times alpha, and that's what we have here. This is basically, again, a big manipulation of math problem. So you just simply prove that, how much energy coming in, right? And which is S over 4, and this is how much energy coming out. When you manipulate all these alpha, S, and numbers and everything, there are lots of simplifications, and you have just S over 4 left. Now you show S over 4 as input and S over 4 as output. That's part B. Show that the surface temperature is 288 Kelvin implies that T equals 0.556. In this case, we have to assume the temperature is 288 and then to show T equals to 0.556. So what do? Is that we use that Wien's displacement equation. So power equals to sigma T to the 4, and that's basically um, the power, which is the I1 representation. I1 right here, I1. So I1 equals to sigma T to the 4. We know everything here except T. Okay, so there's a little t, small t here. We know alpha, we know albedo, and we know S over 4, which is 350 watts per meter square. We know the temperature, 288. So put all these here back into the equation and just isolate T. And that's how we figure out T. Anyway, my second 5 minutes is almost up, and I don't have time to look at part D now. But so far, if you get part A, B, C, hopefully you'll get part D. Okay, bye.